system over 5 years, if we could get rid of those costs, it'd be equal to a $1 billion no-cost subsidy to the industry. So a real boon to the industry. So we went to the legislature, we made our case, and the way we made the case initially was saying, look, we want to register solar systems the same way we register cars. Why is it that a 5 kilowatt solar system on a roof needs so many more loopholes and delays and costs than a 2-ton SUV that careens down the interstate and has far greater environmental impacts? We made that case. The legislature was willing to talk, and we ended up working with the utilities and finding that, look, the utilities actually did want at least some type of a window to be able to review and make sure that a system worked for where you were putting it. So we essentially established a 10 business day waiting period where the registration process is you file the form, it's literally one page, you'll see it on the next slide just so you know I'm not making it up. After 10 days, if you don't hear from the utility, you put the system in on the 11th day, and that's it. Again, free, and it does apply to ground and roof mounts, and then just to kind of cap it off, after a successful implementation over the course of 8 months, we were able to expand it up to 10 kilowatts to better accommodate more residential systems and smaller commercial systems. This is the form. It's as simple as that. I believe we have it on our website, a lot of renewables as well. But it's fast, it's easy, it's 10 kilowatts and below. It's consumer friendly. If you think about how normal markets sell products, you don't sell something and then wait 45 days or wait 60 days or wait 90 days or even more to actually give the customer the product. This is something that actually fits with the marketization and the adoption of solar, in that it is consumer friendly and similar to registering a vehicle. Obviously a vehicle actually now is a little bit more in depth than this, but that was our argument. And just doing some quick math, the first 100 systems that went in, that took 1,000 work days on the bill that was carried by the business, compared to the average of 45 days, 4,500 work days. So you look at that extrapolated over dozens and dozens of systems, or in some markets, New York could be doing far more than what we do in Vermont. That could be thousands and thousands of business days that folks are able to kind of clear their books and start making money off of these systems. And then the last slide I have is essentially a challenge to this group and to the industry that this isn't so far-fetched. While many folks think Vermont is very boutique for various reasons, we do take our land use very seriously. We don't have the hottest solar market in the country, but I don't see a reason why we wouldn't see or couldn't see an arms race among municipalities, whether they be in the state of New York, or an arms race between states about who's going to create the best, most conducive, most solar-friendly market. And I think this is a model for how to do so. In a sustainable world, in a more renewable world, we need to have fewer regulations and not more. We got to make it easy for consumers to say yes, that they want to go into this industry. And that is, that's it.
Just what's the sort of the scope of the permitting? Does it also deal with sort of the local electricians and the roof inspectors? And I know just from my experience, I put a new water heater in my house. It took me 40 days just to get the checkbox from the DC inspector, and that was a water heater. I'm wondering, how all-encompassing is this sort of permitting process?
Yeah, and I'm happy to answer more questions after folks are done, but no, not at all. Essentially the RCPG process, which the 10-day registration falls under, it's a subset of that, essentially exempts all local zoning, code, and inspection. And so essentially we're saying, or the legislature and the regulators are saying, that these systems are small enough that they are certifying certain things, UL listed, et cetera, and that they are going to be safe. And so the only place where we've seen a challenge to Section 248, which is the code in Vermont that allows for this exemption, is in the city of Burlington, where they do have electrical inspection, and they're the one municipality that's essentially pushed back on 248 and said, no, we think we still have jurisdiction over electrical and building inspection. Other municipalities that have similar code have essentially accepted the Public Service Board's recognition of these projects as being exempt.
thank you.
Is this on? Yes. Okay. Hi, I'm Margaret Jolly, distributed generation ombudsperson, as Randolph introduced me earlier this afternoon. Meaning that I deal with customers that are installing cogen, distributed generation, but generally that's a lot of PV, not a lot of megawatts yet anymore, or large megawatt numbers of cogen, not a lot of projects, but again, sort of a large pickup on both of those. So I deal with customers, and I deal internally trying to get our engineers to understand that they can't really sit on these projects for that long, even though they'd like to get everything perfect. And also to get our engineers to understand that they're not responsible for the Department of Buildings jurisdiction. Those are just some of the fun that I get to have at Con Edison. So Con Edison, this is the public utility. This doesn't show what our subsidiaries are doing, and that's a lack. I think I'll add that onto our next slide the next time I do this presentation, because our subsidiaries, Con Ed Solutions and Development, are doing a lot in the solar world. And as of last year, petitioned the Public Service Commission to be able to do solar projects, renewable projects in New York State. Got that permission, which added some reporting requirements on our part. But again, we are doing lots and lots of megawatts on the unregulated side. And I usually find out about those in the same press releases that you would. So we're the electric, gas, and steam provider in New York City. And this map shows the different regions where we are and aren't the gas and steam provider as well. Historically, you've probably seen a slide like this before, but this shows historic delivery of electricity to customers. And as we're seeing more and more customers making choices about their energy usage, either on the efficiency side or for distributed generation, building management systems, storage, different types of storage. Ice storage is also getting more and more popular in the city. Putting the customer at the front of this really turns upside down planning, operations, forecasting, and how we think about operating our system. Lots and lots of interconnection applications coming into Con Edison. One very important reason that we need to expedite the process. Not only does it add cost to the customer and the developer, but it's a lot of time for us to process applications that up until fairly recently we would treat a simple project that might take, as you heard earlier, 2 or 3 days to install. We would treat that, go through the same process that a complicated cogen project might go through. Department of Buildings also would handle those jobs in the same way. So really big push to try to make this easier on ourselves, our customers, Department of Buildings, and also working closely with NYSERDA on what some of the handbooks were. This just breaks down by technology, the applications. Again, large number of PV applications, large megawatts on the cogen side, but definite increases on both, and a need for us to understand the impact of the interconnection, as well as being able to process and understand the impacts. These are, NYSERDA is a great repository for information on costs. This is 2010 installed costs. The next slide will show what those costs are. In last year, you'll see that they've gone down, but this breaks down the cost by county. Much higher in New York. It's much more expensive to do business in New York City because, again, labor costs, complexity of interconnecting in sort of smaller spaces, and this is where we are now. Again, it's a big jump, but still around over $9 in New York City. You've seen this slide before as well. Balance of system costs, if anything, and definitely compared to other costs, have not gone down. And I'll come back to these later if there are questions about technical interconnection considerations, but a networked grid is a complicated system that, again, has been designed with this one-way flow in mind. All the electrical protection, the customer protection, fusing, protection of the network, relay settings have all been designed with this one-way flow in mind. And so when you connect a generator at the customer side and have the energy flowing backwards, it stymies that protection system. And so there's a need for us to address that and understand what has to be done so that we don't have impacts on neighboring customers. you have the energy flowing backwards from the distributed generator, from the customer side, you can also operate that protection. And while it seemed like it might be unlikely that a small generator on a large network would actually be able to flow backwards enough to operate some of these network protectors, we've been seeing, even at sort of fairly low penetration levels of PV, we've had network protector operations in certain areas of the network. On the weekend, not a lot of flow across the network. The transformers are lightly loaded. It doesn't take much to go back and open one of those network protectors and then black out some of the neighbors, because when these network